Now look at this data. It shows data for two equilibrium situations. So note that this data differs from the previous data we've just looked at, in that the initial and the final states are both in equilibrium. Just now the initial was not referring to an equilibrium situation, only the final. Here they are both in equilibrium. Then some stress is applied which disturbs the equilibrium, stops the system from being in equilibrium for a while. In other words, the rates of the forward and reverse reactions for a while, for this period of time, are not equal to one another. And then after a while, then a new equilibrium is established, as shown by the next data. So what I want to know is, what was the equilibrium constant in the original equilibrium state? What stress was applied? And what effect did that stress have? And then what is the new equilibrium constant after a new equilibrium has been established? And what do you notice from all that? Pause until you've done that yourself. The equilibrium constant Kc for the original equilibrium is 64. The stress which was applied was an increase in A's concentration as well as an increase in B's concentration. In other words, an increase in the concentration of the reactants. For a while, that caused the forward reaction to be at a greater rate than the reverse. In other words, equilibrium was disturbed. Now, you need to be careful, because if I say to you that the forward reaction was greater than the reverse reaction, or if I say the forward reaction was favored, or if I say the reaction is shifted to the right, I'm referring to the period of time for which the reaction is not in equilibrium. But if I had rather said that the reaction lies to the right, or lies to the left, then I would be referring to the periods of time when the reaction was in equilibrium. So lying to the right and left refers to a system which is in equilibrium, and it refers to the relative concentration of reactants compared to products. So we can see over here in this reaction, the reaction actually lies to the right, both in the original and in the new equilibrium. Why? Because the ratio of product concentrations to reactant concentrations is in favor of the products. There are more products in comparison to reactants. You can see that in the data. So that means that once equilibrium has been reached with these particular chemicals at this particular temperature, the system lies to the right. There are more products than reactants, and that's shown by the Kc value being large. A Kc value of 64 is large. So yes, in both the original and the new equilibria, the Kc value shows us that the equilibrium lies to the right. But that's got nothing to do with what I was saying about during the stress situation, the reaction is shifted to the right. The forward reaction is favored for a while. So to sum up, the reaction shifts during the disturbed period of time in such a way as to counteract the disturbance that was brought about. Because the disturbance that was brought about was an increase in concentration of reactants, and so the reaction shifts in such a way as to try to use that excess up, and then after a while, a new equilibrium is established with the same Kc as there was before that equilibrium had been disturbed in the first place. What would have happened if we'd rather decreased instead of increased the concentration of the reactants? The reaction would again have shifted in a way so as to counteract the disturbance that we caused. But this time the disturbance that we're causing is decreasing the concentration of reactants, and so it would react by trying to increase that. In other words, the reverse reaction would be favored for a while until a new equilibrium would be established, and that new equilibrium would have the same Kc as the original equilibrium setup had. Now notice that in both cases, before the disturbance and after the disturbance, the ratio between products and reactants would still be the same ratio and also would still lie to the right. So the disturbance of favoring the reverse reaction for a while doesn't cause the reaction in equilibrium state to lie any differently. It lies to the right just as much in the original equilibrium situation as in the new equilibrium situation.